all conic sections, basically. I'm sending you something right now.
Okay.
Just a second.
Yeah, these are always fun days.
Mm-hmm.
Kidding. I love tutoring, don't get me wrong. But 5 and 6 hour days are brutal.
Oh, oh yeah, because you're swamped from
I'm swamped because everybody's having finals, and then I'll go to 2 days from now, I won't have any work at all. But that's life as a teacher, I guess, whether you're a tutor or a teacher.
Mm-hmm.
Kind of looking forward to the beginning of it, but I'll get tired of that quickly. I miss tutoring. I prefer to have days with tutoring rather than days without.
Uh-huh.
All right. Let me blow this up a little bit. You want to start at 1?
Yeah, I kind of want to get through like a little bit of everything on this paper, if possible. Like a couple questions of each type of question.
First of all, what kind of a conic section is this?
A? You're talking about A?
Hold on a second. Yeah, what's A?
That is is that an ellipse?
Uh-huh.
Yeah.
And that's all at once. In other words, it doesn't want you to graph it or solve for any defining points. It's an ellipse because it fits the definition of ellipse. But the biggest reason is that is a different number than that.
Uh-huh.
If those numbers are the same, then it's a circle. Notice that if this was a 16, I could multiply both sides by 16 and I would have the standard equation of a circle.
Uh-huh.
What makes it an ellipse is the denominators are different.
Yeah.
Okay, B. What is B?
B is a parabola.
Correct. And it's of the form x equal y squared. Do you see why I say that? It's not x equal y squared. It's just of that form. In other words, it's the y that's being squared, not the x. So what kind of parabola is it? Is it a vertical or a horizontal?
Horizontal.
Yeah, they didn't really ask that, but they should have. The next one, what are we looking at?
A circle?
Hmm?
Yeah, thought so.
Because the coefficients are the same. That's a 1 and that's a 1, and they're both terms are being squared. So that's a circle. Now, D. First of all, we want to put it in a format that's a little easier to see what we're talking about. So how would we put it into that new format?
Would you add y minus 2 squared?
Yep. So here's what we have. Now what is this?
It is another it's another ellipse.
Correct.
Since their denominators are different.
Yeah. Now, do they ask you about whether they're horizontal or vertical ellipses? Because what matters is the denominator. If the y term has the bigger denominator, it's a vertical ellipse. If the x term has the bigger denominator, it's a horizontal ellipse.
Okay.
Okay? And finally, E. What is E? Of the general form, what is E?
It can't be a circle.
Right?
So
the thing to notice is that only one of the variables...
It's a parabola.
Yeah,
parabola.
That's only true. In other words, whenever one of the variables is not squared and the other one is, the only thing it can be is a parabola. Because circles, everything is squared. both terms are squared. Ellipses, both terms are squared. Hyperbolas, both terms are squared. Doesn't look like you've had hyperbolas yet, but with a hyperbola, both terms are squared also. So whenever you see one term is not squared, you know it's a parabola. It's just a question if it's a horizontal or a vertical parabola. Well, what's this one? What kind is this one?
Oh, is it horizontal or vertical? It is horizontal. Wait, horizontal?
The basic form is y equal x squared, correct?
Yeah.
What
Oh, but it's...
have you been learning for 3 years that is y equal x squared? Vertical parabola, right?
Yeah.
In other words, not just vertical, but the parabola that goes through the origin like that. So when you're looking at y equal x squared, just tell yourself that's what I've studied for 3 years, is y equal x squared. It's only recently that you've even begun to look at x equal y squared. And the reason is that these aren't functions. Notice that the horizontal parabola does not pass the vertical line function test. So you've never even encountered an x equal y squared until you got to conic section. And that's what matters, whether it's horizontal or vertical. If it's of the form x equal y squared, or if it's of the form y equal x.
Okay.
How about A?
Sure. That one is up.
Good.
Up. Wait. Yeah, up.
Here's why it's up. First of all, it's of the form y equal x squared, right?
Yeah.
And which means it's either up or down. And
Yeah.
it's up because that's positive.
Yeah.
If it was negative, it would be down. Okay? The next one is of the form x
equals y
squared.
So it has to be left or right?
Correct.
So it's going to be left since it's negative?
Negative is to the left, opening up to the left. Positive would open up to the right. But this is negative, and it doesn't really matter whether that's in front of the y term or the x term, because clearly I could divide both sides by -3. I've still got a negative number. Although this is where you want to look, for sure. That's A. And that, it's whether that is positive or negative or not. Okay, the vertex of 3A is what? Notice it's in vertex format.
It is...
Here's vertex format. Where H is the x-coordinate of the vertex, K is the y-coordinate of the vertex. So what's the vertex? What's H?
H is -4.
Hold on.
Or just 4.
+4.
Yeah, just 4. So 4 with K is -6.
There you go.
So it's just 4, -6?
Uh-huh.
Oh, wow.
Yeah, once you have it in vertex format, that's why that's such a common format and such a valuable format. That's why they have you complete the squares in order to get into this format. Because once you get there, then it's real easy to figure out how to draw your parabola.
Okay.
And that's a vertical one.
Mm-hmm.
Okay.
So
Now,
for B, you gotta complete the square.
yeah, the next one you have to complete the square. But not only that, this is a x equal y squared one, right?
Mm-hmm.
So, first of all, what's my first step?
Does it get x on the left side?
Get your y terms all
Yeah. You're right.
When you complete the square, you're going to put those two in parentheses.
Yeah, so you have
What
to...
I really have is y squared minus 9y. Leave room to complete the square. Plus 14 equals x. Now, because this is a parabola of the format x equal y squared, well, the general equation is no longer up top on the right here. That's the general equation for a y equal x squared parabola. But if I want the general equation for this kind, it just switched the variables. Y minus a squared plus h. Okay? So we want to put it into this kind of format. Well, we're close, right? Complete the square inside the parentheses. What do I have to add?
So x equals a...
Well, hold on. The next step is to complete the square. We've got everything very close to our general format here. We just need to turn that into a linear term squared. We need to turn it into a y minus k squared. And the way you do it is by completing the square. Once you complete the square, I'm going to be able to write that as whatever I will, but I'm guaranteed to be able to write it as a linear term squared.
You just divide it by itself?
Divide the y coefficient by 2 and square it. That's
okay.
That simple, and it's that straightforward, and it's always that.
Never yeah, I remember when we did that.
Now, I just added 81/4 to the left side of this equation. Well, you can't arbitrarily do that. I can only do it as if I counterbalance it. Well, I don't want to counterbalance it on the right side of the equation. I want that thing to stay x. That's part of my standard formula. So I counterbalance it on the same side of the equation by subtracting 81/4. And now I haven't changed anything. In other words, this equation that we're looking at right there is the exact same thing that I have now manipulated into this. But the fact is, I can now write that quadratic term as y minus whatever I got when I took half that coefficient squared. And then combine those two numbers. That's minus 20 1/4, that's 14, so that's minus 6 1/4. And there's your answer.
So it would be not like -9/2 comma -6 1/4.
Yeah. Now this is a horizontal parabola, so its vertex is going to be at minus 6 1/4 plus 9/2, somewhere right there. And it's going to open to the right. So it's going to be something like that. But the only thing they really asked for was that vertex. That vertex is still h comma k. It doesn't change to k comma x. In other words, the h always goes with the x term, the k always goes with the y term.
Wait, why is it plus, why is it positive on the y coordinate?
Because it's y minus k. Notice up here, for the same reason the last time it was a positive 4. Even though it was x minus 4, that means your x coordinate of the vertex is positive 4. Remember, the standards are always x minus h and y minus k. It won't be until you get to calculus that you'll ever run into an x plus h. So always remember that no matter what kind of an equation you're dealing with, if you're talking about an x and an h, it's x minus h. Okay? And that means that when they give you x minus 4, it means that h is a positive 4. And in our equation, for question B, k is a positive 9/2. And h is a negative 6 1/4. In other words, there's h. And we got an h of that. Well, it's supposed to be plus h over here. Now, I just said that you'll never run into an x plus h, and that's true. Notice where that h started. Started on the left side as an x minus h. It's only a plus h because I moved it to the right side to get to this format. But it still is not x plus h. It's still x minus h. It's just that it's a positive h, which means the x coordinate is negative 6 1/4. All right.
Okay.
Let's see. All right. Focus and directrix. When you are dealing with conic sections as parabolas, they actually use a different format. In other words, remember what the vertex format is? It's this. But that's not what they use when they're dealing with conic section. What they use is this. Now, those two are the same thing. And there's a relationship between A and P. A is equal to 1 over 4P, or P is equal to 1 over 4A. Both of those mean the same thing. So notice that if I were to write 1 over 4P for A, and then multiply both sides by 4P, I get that 4P right there. And if I first subtract K, I get y minus K. So really, these two formats are very much similar, and you wouldn't even have to use the second format if you always use that conversion factor. But for some reason, they feel it's more appropriate to write the general format in this bottom way. And one of the reasons is that it's extremely easy to figure out now what P is. In other words, what am I looking at? I'm looking at 4y equals x minus 4 squared minus 60. Well, if I bring that 60 over to the other side, I get 4y plus 60 equals x minus 4 squared and if I factor a 4 out, I'm left with this. That is our exact format that we're looking for. What's P?
1.
Correct. Where's my vertex?
That's at 4 comma negative 4?
Here's the K, here's the Y coordinate right there.
Oh, 15. Okay, so
But negative 15. In other words,
oh yeah, because you
there's
flipped
the
it.
standard.
Yeah, you
Standard is
yeah, you
Y
flipped
minus K. So if I've got a Y plus 15, then it must be a minus 15.
Yeah.
P is 1. And that's all I really need to know, pretty much, to graph this thing. Do they want us to graph it? Yeah, find the focus and the directrix. Okay. First of all, this is a y equal x, so it is a vertical one opening up. See how I know that? It's y equal x squared, that makes it vertical, and there's no negative sign in front of the x, so it must open up. So my vertex is way down here at 4 comma minus 15. I know the thing opens up. Where is my focus? What are the coordinates of my focus?
4 negative 13.
Negative what?
13?
P is 1.
Oh.
So it's got to be 1 unit above the vertex.
So 14.
And where is my directrix? The directrix is always perpendicular to your line of symmetry. The line of symmetry always goes through the vertex, and it's called the line of symmetry because the parabola is symmetrical about it. What's the equation of the directrix? And the directrix is always the same distance from the vertex as the focus is. So what is the equation of this line? In other words, the vertex is a point, the focus is a point, but the directrix is a line. The equation of that line. The horizontal line, so it must be y equals something.
Y equals
that distance right there is same as P. That's 1.
yeah.
So what's this point that it goes through?
Negative 16.
So y equal negative 16 is the equation of that line.
Okay.
Okay? That's how you do it. Basically, once you find the focus and the vertex, you're home free on these things.
Yeah.
Because, or I should say, once you find P and the vertex, you're home free. The vertex is always the most important point to find. That tells you most everything about the curve. But to solve for the focus, you've got to solve for P.
Mr. Cowan?
Yeah.
Are you booked for tomorrow?
Well, here, let me have a look. I think I got it. I'm not fully booked, I know that.
Well, what time did you have open tomorrow?
Well, can you see my schedule here? I'm booked from 3:30 to 5:30 my time, so before or after that?
Well, you're 2 hours before me, so...
Yeah. So this time right here would be 7:30 your time.
What's the earliest time? The one right before Simon's shop?
Right before 3:30 my time, which is 5:30 your time.
I'll go for the 5:30. Can you move my Thursday appointment to tomorrow?
Sure.
Instead?
Yeah. You want it to be at 5:30 your time?
Yeah.
Which is going to be 3 o'clock. I'm sorry, I don't have 3:30 open.
Oh, it's 5 o'clock.
I misread my calendar. Does 5 work for you? Your time?
Actually, maybe I should do it a little later than that, just in case. Actually, no, it'll work. It'll work.
You can do 5 tomorrow?
Yeah.
Okay. So that's 3 o'clock my time, 5 o'clock your time. I will text you a meeting ID number, and then you don't want the Thursday session?
Yeah.
If you want one, you can always get it. You can see my schedule. It's thinning out drastically.
Yeah, but the thing is, my test is on Thursday, so there's not really, like, I'm not going to have any information to bring you. I'm not going to really know what I'm doing next.
Oh, on this Thursday?
Yeah, so I thought might as well just...
Yeah, that's fine. I don't care.
We're probably just going to go over the same sheet.
Okay.
Finish it, maybe.
Sounds good. I'll talk to you at 3 o'clock my time tomorrow.
Okay. Do you mind reminding me sometime?
What's that? I'm sorry?
Do you mind reminding me sometime?
About tomorrow's session?
Yeah.
Well, I don't know if you get an email or not.
I'll remember.
Do they send you an email? They don't send you an email like half hour before your session all the time?
I think they do, but I don't get notifications for my email.
So
I'll remember that.
The only way I remind you is I'll set an alarm on my phone. And
No.
I set an alarm for 2:55 now, so I don't forget the appointment. But in terms of reminding you earlier than that,
no, it's fine. Do you have a session to go to?
I'm sure you can set an alarm on your phone. You know how to use the alarm on your phone, don't you?
Yeah. I'll remember. I'm gonna remember.
Those are great things to use, is those alarms on smartphones. I use them all the time. They work great.
Anyway.
Okay.
Have a good one. I'll see you tomorrow.
Talk to you tomorrow. Bye-bye.